This video is going to talk about the graphs that we use in Principles of Microeconomics and what you need to know about the graphs. We do use a lot of graphs. You're not going to have to draw graphs on exams or assignments in this class, but you are going to have to be able to look at graphs and read them and figure out like what's going on when we have supply and demand and other graphs in this class. So we'll first start off by talking about reminding you all of what the slope of a curve would be. The slope, remember, the probably easiest way to always remember is just the rise over run. That's one thing that, 40 years later after learning it, if you just remember rise over run, that's a very good shorthand way of remembering what the slope is. Or then if you have a variable at y on the y-axis and x on the x-axis, it would be the change in y divided by the change in x. So if you were going to calculate that, if you have 2 points here on some curve, you want to figure out, well, what's the slope between these 2 points? Well, you would simply go ahead and apply this formula here, the change in y over the change in x. And we can see that this point here on this curve is at the coordinates of 4 and 8. 4 on the x-axis, 8 on the y-axis. And it also goes through point 10, 13. 10 on the x-axis, 13 on the y-axis. So what we do is if we're going to calculate this slope here, we say the change in y, well, it goes from 13 to 8, so it would be 13 minus 8 on top, and then 10 minus 4 in the denominator. So the first number in the formula should be really the second point that you have here. So the first number here should be 13 because you end up at 13. You went from 8 to 13, so the change would be 13 minus 8. And then you went from 4 to 10, so 10 minus 4 shows you the change in x. Most importantly, if you're calculating this and you have it set up like this, and if you want to know, did you put the numbers in properly, the numbers from the second coordinate, from the coordinates should always line up. So this should be like the second one, this is the first one. Actually, there's no difference. If you flip this, if you had 8 minus 13 and 4 minus 10, that would end up giving you the exact same number. So you have this, and then it's just very simple arithmetic to reduce it some, and you see it would be 5 over 6, and that would give us the slope of this curve. And we can see that this would be, we have a positive number here in the numerator and a positive number here in the denominator. Now, I don't want our class to be a lot about doing a lot of math, because the math is relatively simple. Even though we could set up this class doing a lot of calculator math and ask you to like calculate the slopes on different curves. That's not what I want the class to be about. I don't want people, especially if you struggle with math at all, to spend a lot of time trying to worry about calculating slopes. So you're not going to have to do a lot of calculations like this, but there are some things you want to be able to do to be able to observe, to be able to make sense of graphs when we show it. And one of the important things would be to show that, to make sure you can tell which curves are positively sloped and which curves are negatively sloped. So positively sloped lines or curves would look something like this. Because again, when you think of positively sloped, we had a positively sloped, we ended up with a positive slope here when we did this. So if for a positive slope, you'd have to have both x increasing and y increasing. So if when you're comparing 2 points on the curve, both y is getting bigger and x is getting bigger, then you're going to have a positively sloped curve. These would both be positively sloped curves. If they're negatively sloped curves, are going to look something like this. These would both be negatively sloped curves. And with a negatively sloped curve, you'd have to have a change. When you have 2 points here, you'd have to have the rise either being negative, or the change in y being negative, or the change in x being negative. So you'd have to have something like, if you're comparing 2 points here, you'd be going from, like, say, 3 and 7 to a point down here that might be 8 and 2. And so either, that could be 2 points, say, on this curve here. And when you're comparing them, you see, well, x gets bigger, but y gets smaller. Or if you want to think it the other way, x gets smaller, but y gets bigger. When you're comparing 2 points on a curve, if the changes go in opposite directions, that's going to be a negative slope. So again, to be able to make sense of the graphs and be able to easily, interpret them, one of the things you're going to want to do is make sure you know whether you're looking at a positively sloped curve or a negatively sloped curve. Because once we introduce demand and supply, the easy way to remember that on the diagram is always going to be, well, the demand curve's negatively sloped, the supply curve's positively sloped. So if you know how to distinguish which curves are positively versus negatively sloped, you'll be able to quickly make sense of those graphs. Another thing is to remember, we're going to talk sometimes about the shape of a curve. In particular, then we're going to say, is this a line or is it a curved curve? A line, if you remember, is a curve or a function where the slope is always the same. The slope doesn't change for a line. So if you took any 2 points on a function here on a curve and you calculate the slope between them, if it's a line, any 2 points there are going to give you the same answer when you plug this in here. So the slope of a line is a constant. And so with a line there, a line, it has to be straight. So we have straight lines. So remember that we have straight lines, and then sometimes we're going to have curved shapes to them. So in some of the cases in this class, when we introduce a new curve, one of the first things we're going to do is to pay attention. What is the shape of this curve? Is it positively sloped? Is it negatively sloped? Is it a line, or are we going to make it bold? Those will be the things we would want to ask. So a line would be is straight and has the slope calculated through any 2 points would be the same. And then sometimes we'll have curves where if you chose different points along that curve to calculate the slope between, you would get different numbers depending on where you're calculating the slope. So those are sort of the basic things you need to know about graphs. You're not going to have to calculate slopes a lot, but you're not going to have to calculate that. But it really helps if you're looking at a graph. And another thing will be helpful is if we have two different lines there, if you can quickly remember which one's steeper and which one's flatter. So if we have two lines like this line, well, assuming that they're both lines, I put a little bit of curve on there, perhaps. This one's steeper than that one. So this one, the slope would be steeper. So that's another thing that we'll talk about. Sometimes we'll talk about demand curves and supply curves once we introduce them. And we'll want to talk about how responsive demand is. And that's going to be related to the slope or the elasticity of the curve. So when we're drawing a graph, we might have two demand curves in there, and we want to be talking about the one that's more elastic or inelastic, and they'll have different slopes. So another thing that would be helpful for you, if you can easily recognize when you have two curves on the same graph, which one's steeper and which one's flatter. We're not going to do a lot of powerful stuff with graphs, with graphs or numerical calculations. But if you can get these basic things about, remember what the slope is, the rise over the run, what's positively sloped, negatively sloped between two lines, which is flatter, which is steeper, and then what the difference between a line and a curved shape is, that'll be what you'll need to know in terms of handling the graphs in this class. So that's a brief review of graphs.